2016 TSJC Robotics team, and this year we've been working on Sable. Sable stands for Scoop and Bucket Land Explorer. I am Hayden Allworth, and I am the captain and the programmer.
I'm Jennifer Kamars, and I'm the sensor designer.
I'm Melissa Bedini, and I'm the builder.
I'm Josh Hoffpower, and I'm the electronics designer.
I'm Richard Maldonado, and I'm the 3D designer.
So, Sable has basically, not only does Sable have to basically navigate through terrain and avoid obstacles, this year Sable actually has an extra credit challenge to complete, which is finding, picking up, and bringing back to us an orange golf ball out in the sand. And Sable has to find the orange golf ball scattered amongst other colors like yellow and white and green. So Sable, basically we have it so that we can switch out from the bucket and the pixie sensor, which finds the orange golf ball, and we can switch in the laser rangefinder. And the laser rangefinder basically allows, when Sable is not looking for the golf ball and is just navigating, it allows Sable to be able to actually find and pick up, not find and pick up, but find obstacles and avoid obstacles. And we can basically just switch them out just by sliding it out and up, and then sliding whichever one we need back down and in. Like this. So also Sable, to navigate throughout the sand, Sable has a flexi-force sensor, and this detects anything that could make us high center. Sable also has sharp IR sensors, which can detect basically a pit hole, so Sable won't fall in any pit holes, and ping sensors for wall and rock avoidance. Josh actually did the circuit board for Sable, and as you can see, there is the circuit board.
Now this is the 3.4 version of the board, as opposed to the Sable 1 board, and the reason that it's 3.4 is because it was such a step up, or such an improvement from the original, also with its dark green color.
And so, to help Sable navigate, we put a kill on Sable, and that allows Sable to basically get itself off of anything that she high centers on. Also, from previous years, we modified the wheel design a little bit, and we made the wheels basically curve inwards, which makes them lighter. So that means that we can actually make the wheels taller and thicker while still being lighter than previous wheels. Sable can navigate and avoid obstacles either by using a compass and going to a certain heading, or by using this beacon, which sends out angles and tells Sable where it's at. So Sable can navigate either just by compass or by actually going to the beacon. Also, we have two buttons on Sable. That way we can basically tell Sable which angle to go to and what we actually want Sable to do. So, and then we have an LCD screen, and that just tells us just basically what Sable's doing and information for debugging purposes. We have this dome to put on Sable, and we just screw it down, and it's basically just to keep everything sand out and like any kind of rain or anything like that out. So basically all the circuitry stays good and clean and doesn't get affected by the sand. That's also why we have these little boxes to keep the wires from getting sand in them.
Good idea. I'm going close.
Now,
Going close.
looking at different parts of the bucket? Are you okay? Looking at the little pixie. Oh, no, we're not doing that. There's our circuit board. Put the dome on. Okay. Thank you for the butt shot. Okay. There we go.
I'd like to
Okay.
give special thanks to our advisors, Cindy Clements, Karen Howell, and Earl Nesbitt, and they were for helping us basically throughout the building and design process. So this is the beacon we built, and it has this part. Just all this does is just makes it rotate around, and it's supposed to have a battery here, and then this just controls the speed at which it rotates. Up here is the actual part that sends out the values, and
Might fall out.
so this just has a 9-volt battery to supply power, and an XB. The XB is actually what broadcasts. It broadcasts out with this patch antenna, and then this red board right here, this is a FIO, and the FIO basically just gets the heading from the compass, which is right here, and broadcasts it out through the XB. So, and that's basically how it works, and it's constantly rotating around, telling what the angle it's facing. And so anyway, the robot is looking for the strongest signal from this, because the strongest signal means it's facing the robot. So then the robot has to invert the angle by 180 degrees, which would be looking straight towards the beacon, and then travel that direction to get to the beacon.